All right, so I'm starting the recording and just make sure everyone is here and we have maybe 15 students attending the class today and one is coming later. So you can stay in the room after we finish the lecture, you can talk to me and then we can mark you down. So first we will take a quick review about what we have learned for the conceptual estimating. Okay, so this is the topic we have learned in the past couple of weeks. So the first one we learned, first method we learned is called weight unit cost, which we get in the UC is equal to A plus 4 times B plus C and divided by 6. And then we using the cost is equal to UC times with size. So this is the first method we learned. So and the A here is the minimum unit cost, and the C here is maximum unit cost, and the B over here is the average unit cost, right? So that is quite easy. We always refer a table and using the table to define A, C, and then we have a unit cost column. We getting the total and or we using the total, the unit cost divided by the number of the project in the column, we're getting the B. And then we will be able to perform the UC and getting the cost for the project. So that's the first one we have learned. So the second one we have learned is called the unit cost adjustments. Then we will refer to plots. Maybe zoom in over here. So we refer to a plot. And this one we have the X and we have the Y, and then we will have a plot like this, and all those past data is running this straight line. So we call this one is Y is equal to AX plus B. And we know Y here is the, so this Y over here is the cost per unit. And this X over here is the unit, right? So then we need to find in X1, X2, and the corresponding Y1 and the corresponding Y2. So we're getting X1 is equal to Y1 is equal to X1 A plus B, and Y2 is equal to X2 A plus B. So we have the two equations, and we using 1 minus 2, we get A, and we put A back to equation 1, we getting B is equal to what? So then we can define for the given X equal to any size or the unit. Then we're getting Y for this X, and then we're getting the cost is equal to size times with Y. So this X. So that's the second one we have learned. So for here, the X is the smaller size, right? Is the minimum of the size. And the X2 is the maximum of the size. So both of them are from the table. So so that's the two methods we have learned, and we already did the quiz. So and I also asking you guys to do the assignment 1. For this is assignment 1. Number 1. This is question 1, and this is question 2. So any questions so far for those two methods, and any questions so far for the assignment, please let me know. All right, so if no question, so today we are starting to learn the third methods, which is the adjustments, right? So we have done with this weight cost methods, we have done with the unit cost adjustment, and today we are going to starting to learn this time, location, and the size adjustments. Okay, time, location, size adjustment. So this will be this week. We were doing today with the learning, and then we were doing the quiz on this Thursday with this one. So let's see how far we can get an understanding for this one. Maybe we will perform one more practice, and then we'll do the quiz. So so that is the table we have go through. Now we move into the size adjustment, right? So for this one, we were going to do the first. We needed to understand what is the time adjustments. So then we were using the index. So the index is from the table, right? And we will do the location adjustments. So we were using the index again. So we will explain what is index in the next pages. And the third one, we're doing the size adjustments. We were using ratio of the size. So this is quite easy. I think that is easy. And that is medium. And this is hard. And definitely you will combine those together, you will get this combined adjustment. So for the time and location adjustment, you will see two tables. So we're using the index. So the table will be shown in the next page. And the size adjustment is quite easy. So basically you are going to have a size for project A is equal to 200. And the size for the project B is 300. So you are going to find what is the unit cost. And that is unit cost, right? And this is your project cost. So basically here is the size, and you will see since A has more units, so basically the total cost for project A is cost much than B, and that is because you have more size, right? So in this case, it's B has more size, 300, and then the project B will be cost much than A. So we will see the examples. So so first we will see we separate into the simple one. So first we will see a time adjustment example. So this one will only deal with time adjustments. So let's read in the problem statement. So for cost information for that amount project completed last year is to be used to prepare a conceptual cost estimate for a project proposed for construction 3 years from now. So with this given information, we'll see we know a project cost, but this project was complete in the last year. And we're going to using those information to determine a project which is going to be constructed in next 3 years, right? 3 years from now. So please using the cost index, which is over here, to adjust the concept estimate. So this is a given project, and we know it's in the last year, and our new project will be 3 years from now. So now I'm going to perform this calculation. So first you need to have is I'm going to add a page here. So first you need to have is a drawing. So that drawing is help you to understanding what happened with the already know project and what will be happen for the future project. So first you need to do this. So you draw a straight line arrow and you define here, you define next mid over here as now, which is now. And you know your project is completed in the last year. Last year means from now you minus 1, so you get a negative 1. So this is a past year. So if you have another project is here that is 2 years from now, does that make sense? So so if you have one project is from now, is we do this here is next year, and here too it will be 2 years from now, and maybe you have 3 here. That means 3 years from now, and maybe you have more. Then you have 4, 5, and 6, and that is 6 years from now. Okay, so that is cash flow chart. So this we call is cash flow chart, and we will using this one to determine our time, right? So so all those horizontal here is a year number. And now we look in our cash flow. So the cash flow is means you have some money investment or spending over here. So in this case, we have last year, which is -1, and we put in here, and we understanding this one is happened with $843,500 project happened over here. So we're going to using this one to determine a project for a construction project for 3 years from now, which is from here. So this is what we're going to determine, all right? So let's count how many years between those. So you will see here will be -2 to 0, you have 1 year, and the 0 to 1, you have 1 year, and the 1 to 2, you have 1 year, and the 2 to 3, you have another 1 year. So the difference between those two is 1, 2, 3, and 4. So this 4-year difference, right? So if you have learned about the economics or some accounting class, I'm going to remove those. You will be able to know something like this. So your future, that is future value, is equal to your present value times with 1 plus I and n. So n is equal to how many years from now? So year difference. And this I is the interest rate. For example, here is the example. You have $1,000, right? And you want deposit to the bank for 3 years, and the bank giving you a deal with the interest rate I is equal to 10%. So please calculate your deposit value in the next 1, 2, and 3 years. Okay, so so that is means you do your deposit and put your money into the bank, and the bank will retain you 10% as pay off your investment, right? So you have your now is present, which is now is $1,000, and 1 year later, and so 1 year late, your future value in the first year, and you will Madison, can you meet? Yeah, in the first year you will have the $1,000. That is what you get from your $1,000 is your own money, right? And your return will be the 1,000 times with this 10%, right? So if we put in those together, we will get 1,001 plus 10%. So this is your first year value, right? And then your second year, by the end of your second year, you will have F2 is equal to F1 plus F1 F1 times 10%. Why I'm using the F1 here is because you're not withdrawing your money. So starting the second year, your investment will be your first year and the money, which is come from here. So you will be including your originally money here, and also you will put in this 10% your return money into the bank again, right? So you will get that one. So if we put in this one out, you will see this will be F1 1 plus 10%. So you are getting P, which is P, this is P, right? Times with 1 plus 10%. And then 1 plus 10%. So you will see a formula like this. So so that basically if you're going to separate this one, so you are going to see so I mean in the future, and you will see the F is equal to P 1 plus I n squared. So I is this one. So that is a general equation, and the F is the future value, and the P is current value, and I is the interest rate, N is year difference. So for example, if we have the year 3, and we are going to have another page here. So if we're going to have year 3, F3 will be equal to P is from the year 0, right? Plus 1 plus I, and here N is equal to 3. Okay, so so that is the equation when you know your current value and you're going to find your future value, and also you know your interest rate, right? And you just need to understand what's the year difference between it. Okay, any question for this one?
Yes, Dr. Yuhan, is N just on I, the interest rate, or is it outside of the parentheses of 1 plus I?
I is on the just interest rate.
Okay, all right, thank you.
Can you say what the F and the P mean again?
F is the future, and P is present. Okay, so future is means later in the future, and the P is now, currently. All right, so if we understanding, so I'm just in explain this why we going to use in this one. Okay, so so now if you already understanding this one, or you can using that equation, that will be quick, easy. So but the challenge over here is we don't know this. So from the given information here, from those given information here, we kind of likely know we may kind of likely know this P, and you may refer this P as this number. And we kind of likely know this N here, because from the table we will see this is -1 and this is 3, and then we may figure out the year difference between those is 4 years, right? And then we can figure out this N is maybe equal to 4. But we kind of likely don't know what is the I. So that is a challenge. Finding the I is a challenge, okay? So then our starting point is for this question is find I, okay? So this is a challenging part. So so before we move on, and let's take a look how to find. Let's take a look how to find the. Let's take a look how to find the n first. So if you're given something like this, so what we do is we always convert this one into a now and the future model, right? So what we do is we can do this. So you know this is your -1 year, and you put in here as 0, and this will be 1, 2, 3, and 4, right? So we convert this one to now, and then this will be the future, and actually you get n is equal to 4 years. So that is a little bit easy, because when you see -1 here, you may confuse. We're getting 3 here, why my n is equal to 4. But if you can convert it to like this one here, so -1 be 0, and the 3 before, that basically is -1 plus 1, this plus 1, plus 1, plus 1, plus 1. To make sure this one is equal to 0, come to here, and then you get that. So that is a way for you to convert this. So the reason I want to do this is because for maybe in somewhere your table, this table, give you the information that will be 1 year from now. But you can see here, this is 3 years ago. Okay. Okay. So I give you so now we're going to find I using the index table, which is referred to this one. So now I give you seconds, like 1 minute, try to draw a cash flow chart. And this cash flow chart is asking you to put in those information here, 3 years ago, 2 years ago, 3 years ago, 2 years ago, and 1 year ago, and the current year into here. So give you 5 minutes to try.
Dr. Yuhan, are we using the equation, the F equals P equation right now? Just
we're not do any equation right now. Okay. We just finished the okay. Cash flow chart.
Thank you.
Yep. Okay, so I'm putting a arrow here, and I'm putting 1, 2, 3, 4 dot over here, because we from the table we will see there's only 1, 2, 3, 4, right? So 1, 2, 3, 4. So is anyone can tell me how to do this one right now? Grace, can you try?
Okay, which side are you starting on? You're starting at 0, like now?
I'm starting from, yeah. Can tell me what I should put in here?
For the now, where the little
Mm,
triangle is at, I would put
Yeah.
the current year.
So you want to do here is a current year. So the
Yes.
current year you will be
Oh.
0.
Wait, no, no, that's not what I have. I have 358 there.
So you have 358 here.
Yes.
So 358 here, that means this is 3 years ago, right?
Yes.
So that will be the number will be -3. Is that correct?
Yeah.
Yeah, you just follow. It's quite easy. You just need to follow this one, right? So then
Okay.
you have the -2 here, and the -1 here, and the current year is 0 here, right?
Yes.
So you have this one is 359, and this one is
367,
367, and this one is
378.
378. So it's okay, but we see here is negative. Negative means the past, right? So now what we do is we will convert this one to something like this. So so we're going to convert this one into a current year model. So similarly, we have here 1, 2, 3. So we need to plus 3 here to getting this one equal to 0, right? 0. And the -2 plus 3, you're getting 1. And the -1, you plus 3, you're getting 2. And the 0 plus 3, you get a 3. So similarly, you have 358, 359, 367, and 378. So this is much more easy to use because you have from the P, and this is your future. Does that make sense?
Yes.
Okay, so now you're understanding here is your present value, here is your future value. So you can getting an equation here is your F is equal to P1 plus I N square, right? Okay, so I think I did a mistake over here is this N here is not only to I, this N here is to the block here, okay? So this N here is here. So sorry for this confused. So let's go back to here to change it to, yeah, here is correct. So the P is equal, F is equal to P times 1 plus I, the N is out of the block, is for this. And again here, we remove this outside, here is N. Okay, so that is a correction here. Since we know this, and could you tell me, Madison, could you tell me this N is equal to what for this chart? Madison?
Is it 3?
3. Tell me how you getting 3.
I don't know. I wasn't really here for that part, but last time you used 4, so I just
Okay, so
followed that.
it's different. So how we're getting 3 is because this is your given information, 3 year, 2 year, 1 year ago, and the current year. So first you are getting this one. So this is your first step, you are getting this one. And the second step, you will convert it into this is 0, and this is your future, and you getting the n here is from this one here. Does it make sense now?
Yeah.
Okay, good. So so for here the n is equal to 3 because we convert all those things to now and the future. So we get n is equal to 3. So another way you can do is you can using this 0 minus -3, you're getting 3. Or you can using here 3 minus 0, you're getting 3. So so I prefer you guys all have those two cash flow chart and show you understanding how you're getting those 3. Okay, so so now we know n is equal to 3. Let's see, the f here is come from this one, p is come from this one, so we will have 378 is equal to 358 times with 1 plus I, and here is 3. Does that make sense? So I'm just putting the number in. And then we were getting 378 divided by 358 is equal to 1 plus I 3 times here, right? And then we will get, we're getting the cubical root here, 378 358 is equal to 1 plus I, and we're getting I is equal to -1. So is that clear? So anyone can tell me I is equal to what? And this number will be less than 1. And in the future, you can get in, that is will be future margin divided by present value -1. So this is a general equation. And please give me this results here. We need to use it.
The 378 divided by 358.
358, yes.
The cubic root of that is 1.018, and then when you subtract 1, it's 0.018. Do you want 4 decimal places?
0.018. Yeah, 4 decimal place, yes.
Okay, and it's a 2 after that.
Okay. So is everyone getting the same results, or anyone getting the different results? Please let us know.
Yeah, she's right. That's what I got, Dr. Yuhan.
Okay, that's great. Thanks for confirming it. So so we were using this number here, okay? So I is equal to 0.0182. 0.0182. 0.0182. So this is our I we have. Now we define the I, we come back to here. So we find I is equal to 0.0182, right? So we come back to this equation. So we know the P. Could you tell me what is the P here if we're going to using this equation? If we're going to find in the propose a project 3 years from now, and we know a project in 1 year ago. Since we already converted this -1 to 0, and 3 years from now is converted to 4, so we understand here, right? So this current year value is this one, same as here, and this future year value is same as here. So that is easy now. We can easily, so I'm going to remove this one here. And we know our n is equal to 4. So your future project value will be your current one. Current one is this 8433500 and 1 plus I is equal to 0.0182, n is equal to 4. So that number will be your final results. Any question here? So who can give me the final results? Josh? Josh is not here?
Give me 1 second. Oh, okay.
Okay, good. Yeah.
I think I might be a little bit off. Is it 906,000 and 603.64?
906,000 and yeah, just reading your number one by one.
906
Mm-hmm.
0 603.
Mm-hmm. So 9060603.
Oh no. Take off that last O. And so it's 906 and then it's 603.
Okay, got you. That number.
Point 64.
Good. We don't need this point, so
Oh, round it
64.
up.
Yeah, we can yeah. We can leave it there. So
Okay.
yeah, we can leave it there. We can leave it there. And 16.4. So is anyone getting a different number, or you all get the same number? 906 603.4 16.4.
Yes, when you use just the 4 decimals, that's the number. But if you're using the full calculation,
Okay.
then it's a different number.
So for here, so for I, you are using 0.0182, and Grace, are you using 0.182 for the I, or using 0.18 for I?
At first I just used the calculation from a calculator. I just added, I just pressed enter and added it into the equation. But then when his number was different, I saw to just use the 4 decimal place.
Okay. Oh, using the number results given the 4 decimal place. Okay.
Yeah.
So do you
So
getting a
that
number?
right.
Do you
If
not
you just
do?
use the 4, that one's
Uh-huh.
right.
So do you getting a number close to this one?
Yes, the number I had gotten was a 906 908.
I got you. Yeah,
Mhm.
because you're using a number big over here and then
Mhm.
increase it. So that's fine. So so that is the time adjustment. So the time adjustment, I think, is a challenge one. So it's starting to finding the I. So the first step is finding the I using the table. So the table is referred to here. So this is the first step. Once you finding your I, and then you are easily to putting back in here, putting back here, and then you will be able to find your project cost from your knowing project, and you know the year difference. So to get in the year difference, you can easily do this drawing and convert it to the second one. So that is the same over here. So when you know your index, you will do the convert as well. So basically, for your results, you will show me four cash flow charts. So this is your first one, second one, third one, and this is your fourth one. Okay. So you will show me those 4 cash flow chart, and that if you show me this 4 cash flow chart, I understand you already know it. I will not grading your the numbers difference. That doesn't matter. I just want to make sure you guys understanding this whole process. Okay. So another source over here is when we're looking this table here, and when we convert it into the cash flow chart and also the second one over here. So when we're using those information to do the calculation, and you will see, basically we're picking up this as current, and we're picking up this as a future, and definitely we getting the n here is equal to 3, and which is the maximum from now to the future. Okay. So so the next time when you're doing a practice, let me give you a quick example here. So if you're doing a practice, you have -3, -2, -1, 0, 1. So you will convert this one into 0, 1, 2, 3, and 4, and 5. So in this case, your n will be equal to 5. Okay. So because you always picking the maximum from here is not to the future. And if you have index here 300 and the index here 400, and then you are using this. So you may have some 3.5 and a 3.10 and a 3.05 in the middle. So we're not going to use those. We're just picking up the smallest one and picking up the maximum one from here. Okay. So then your n is equal to 5. Your n is no longer equal to 3 or equal to 4. Basically, you want to know how to find your n.
Question.
Yes, go ahead.
So it's the smallest and the max. Could the minimum be something, a number in the middle, or is it always
No,
the farthest number to the left and farthest
we're
to the
not
right?
using any. We're not using any minimum number. The minimum always be the left, and the maximum always be the right.
Okay.
Okay, that is because you have the equation determined the f is equal to p1 plus I n here. So this number is always more than 0. And also when n increase and those same increase, and that means the f is always increase. Always increase. Okay. So all right. So that is the case study for the time adjustment. I definitely will posting my handwriting over here to to the blackboard after this class, so you should be fine. So let's move on to the next one. So next one is much more easy. It's called a location adjustments. So that means when you're doing a project in Greensboro and then you may consulting or may considering the project did before in Raleigh or Charlotte, right? Or in the reverse order, doesn't matter. So for this case, you will see a project completed in the city A is to be used to prepare a conceptual estimate for the city D. And please make a location adjustment using the index over here, okay? So what that index means. So so in this table over here, we only see you have A, B, C, D, E, and then you see those index are more than one. This is more than one. But do you know what is those number compare with? So if we suppose, okay, so suppose there is a standard city, and I call this city as X, okay, and has the index equal to 1. So we put in back in this table here, we have city S and the index is 1.000. So let's take a look at it. So the cost in city A divided by the cost in city S will be equal to those index A, because it will be 1.025 divided by 1.000. So this number is here. Is that correct? We can do another example here is the cost for city E divided by the cost of city S is equal to 1.240 divided by 1.000. That will be the index E. So that is how those index come from. So since we know that, so can we try to do something like cost A divided by, or maybe change another color. Cost E, sorry, we're still using A. A divided by the cost in the city E, that will be what? That will be the index A times with cost S. Putting this one back in here and putting this one back in here. So index E times with cost S, and remove those two, you will get index A divided by index E. Does that make sense to you? Or any question here?
Wait, I'm sorry. I missed the part. Why did you put so I see why you did cost A and cost index for S, but why did you redo cost index? Is that E? So cost index for E and cost index for S.
This one,
The second one is the red one.
this one.
Yeah, why'd you do that one?
I just give you one more example. So this is example 1, example 2. And the reason I do it because I want to put in here. I times with this left side here with cost x, sorry, cost s, and then I remove this one and I have it here. So that means cost A is equal to index A times with cost S. As I said, cost S is a standard deviation, so that is a standard city. And in the meantime, you can times with cost S here, and remove this one, and putting the cost S here, and getting this one, and I move to here. Okay. So the equation is going to tell you the cost A divided by cost E is equal to the index A divided by index E. So that's the information to show you here. So from this
Dr. Yuhan, in the green of number 3 of example 3, is that cosine of something you have slashed up?
there's no cosine, is all the cost, cost.
And then in this, the equals the second part with the index.
Yeah, equal to the index A divided by index E. Yes.
Okay, thank you.
Yeah, there's no sine cosine in this
Well,
one.
what is that being multiplied by? Where you have the slashes through it.
I have here is multiplied by the cost S, but since they are the same, so I remove it. So
Okay, thank you.
I remove those two cost S here, and then I get in this one, right? So basically that is the same thing. So so that is useful. So if you agree with this one, definitely we can do a cost A divided by cost B is equal to index A divided by index B. And also you have the cost A, cost C, cost D, cost E, or even how you do the cost B divided by cost E is equal to index B divided by index E. So that's just a repeat things to help you understanding what it means. Now let's going back to the problem statement. So you have a project completed in the city A, and you're going to prepare a cost in city D. So let's circle it. City A and the city D, right? So then you can easily to get in your change another color here. The cost A divided by cost D is equal to index A divided by index D. Or you can do another way. Is cost D divided by cost A is equal to index D divided by index A. So does that make sense? So you can do either D over the bar or A over the bar, it doesn't matter. So if you're getting this one, you will be getting the cost D is equal to cost A times with index D divided by index A. So this equation, both sides multiple with the cost A, right? You're getting this one. So you're getting your cost A D, sorry, is equal to the cost A is given here, 387 times with the index D is 1.105 and index A is 1.025, and you're getting your cost over here. Does that make sense?
Yes.
Good. So Who can give me a number for this one?
I got 417,420. 17
417
and
and
420.
420.
0.4878.
48. So we can random this up. We don't need this number. Okay. So for this conceptual estimating, you just think put in the integer number for the final results will be fine.
What does that say to the right? It
Which
says
one?
cost A times index D over index.
A.
Okay.
Yeah, this is A. So that is the example for this one. So now I give you a practice over here. So we're going to using the same table over here, and using the same project complete in the city A here. So now we're going to do is conceptual in city E. Okay. So we're doing this. We're no longer doing with D. We're using the same information here to getting conceptual estimating for city E. So I give you 2 minutes to do this. All right. So which number I should put in here? Let me asking
387,200.
387,200. Okay. So Trevor, you want to volunteer here, right? So which number I should put in here? Another number put in here.
For the top, wouldn't you put 1.025?
025.
It's index A, and then 1.240.
So why
So
did we use index A, or does it matter?
this is wrong.
Should that be flipped?
Yes, it should be flipped. Yes. Okay. So so we are getting 1.240 divided by 1.025. So because you're going to look at the cost for E, and you knowing cost is, this is cost for A, right? So if you're looking here, cost D, index D, cost A, and this one is in the bottom. All right. So what's the number for here? The last number for the total cost should be more than this one. I think it's more than 400 and some thousand hundred. Yeah. What's the number here?
It's 468
68,000
417.
417.
17.
17. Thanks.
Mhm.
Okay, so I think you all mastered this one. 417. So that is good.
Why did we use cost A
Where?
for
Here?
this equation?
For this one? Because A is a given one.
Okay.
Yeah, and for this is using the same condition. We remove the D, we replace with E.
Oh, I see.
Okay, so you always refer to the one you know, and divided by its index, and the times with you're going to find that index. So this is index you know, and this is the index you're going to find, right? So that's the that is the location adjustment. So that is the second one. So let's take a look at the third one. We may don't have enough time to finish it by today, but we can continue with next week. Okay. So sorry, next class. So this one is a case study for combined adjustment. So the combined means we have the time, we have the location, and also we have the size. So we did not really perform it about the size before, but we did the time and the location. So if we want to see the size, I given a short example here. So for project A, the size is 200, and the project B size is 300. And then if you know the cost for A, then you're going to find the cost for B that equal B. Cost B is equal to the size of B divided by the size of A and times with the cost A. So that is quite easy. So similar to the location adjustments, you are using your knowing size. Sorry, you're going to propose your 3,000 for the B, and you will know cost for A, and basically you're using cost. So this cost A divided by 200 actually is finding its unit cost, right? Times with the 300, the proposed one, you're getting finding the cost for B. So that's the size adjustment. So another thing over here is quite different is because so we were going to using a index here. So let me show a little bit of thing over here. So so the proposed project cost, right, is equal to your knowing project cost times with time index times with I don't have enough space. Let me do another way. Okay, I'll write down. Okay, times with and rewrite it. So your proposed cost is equal to your no cost. That is all the project cost times with time index times with the location index times with your size index. So first we need to understand what is the time index. So the time index is, you have your future value is equal to present value times 1 plus I n squared here. So this part here is the time index. So you have 1 plus I n squared. So this is your time index. Your location index is equal to your index of the proposed divided by your index of your knowing, right? So previously we're going to find the E, this is E, and we know A, this is A, okay? And then the size index is really easy to understand. So the size index is equal to your proposed size divided by your no size. Okay, this is the same. So for the given example we have here is the B equal to 300, and for here is A equal to 200. So those is the location index. And then you have the size index, okay? Location index and the size index. So once you finding the time adjustment index, location adjustment index, size adjustment index, you're putting back to here your proposed is equal to your no project cost times with those index. So for this example, you have the time location in the previous example to prepare for the conceptual estimating for. Okay, so for here, this time and the location index will be using that one as well as this one, okay? To finding your building with this square feet. So this is your proposed one. And the building is to be constructed 3 years from now in city B. So this is your proposed city B and 3 years from now. And your given information is a similar type of the building cost. Those is your given cost. So this is your knowing cost that was constructed by this size. This is knowing size. In 2 years ago, that is the knowing time. In the city E, that is knowing city, right? So so those are the information given here. So what we're going to do is define your let's quickly do this one, okay? So first you are going to find your time index.
Are you gonna go back over this next class?
Yeah, say that again.
Are you gonna go back over this next class? This specific example?
So if you want me stop over here, I can stop over here, and then we can do this one next class, since I already told you. So this is the equation you're going to do, and you have one step is finding the tax index, second step is finding the location index, and the third step is finding the size index, and then you're putting all those back in here. This is your fourth step. So you are finding your project cost. So when you're doing your time index, you can refer to the time adjustments, and you find your location index, you can refer to your location adjustments example. So I would say since we only have 9 minutes left for today, we can stop it here, and then we can perform all those next class in Thursday. We're still doing the Zoom, okay? So please try your best to practice with this one. Since I already explained this question to you, all those with the pink color is the information with a proposed one, and all those with the yellow color is all those knowing one. You just need to figure out which number to put in where. And this F, we're not using F, but we know this P here. We're going to find this one, but we know this P here. I mean, I can give you a more general equation. That will be 1 plus I A and the index and the index and the size divided by size. Pole, and this is no, this is proposed. Okay, so this is the knowing one. So this is a more general sense. This is called, this part is called time adjustment. This is called, including here, location, and this is called size adjustment, and this is your project cost. So yeah, please, I'll posting this one on the Blackboard, and you are given those given information, and also this class video recording to try to practice with this one. And in next class, we will starting with go over this one, and then we will have a continue practice, and maybe if we have enough time, we will doing a quiz for this one. If not, then we will do the quiz in the next week, Tuesday. Does that make sense?
Yeah, that sounds good, Dr. Yu.
Okay, all right, so we can stop here. I'll posting those on the Blackboard once the recording processed. Okay, thank you. If you in the